Hi, my name is Koh Mei. Today, me and my teammates will present on our project for direct data management. The dataset that we've selected is for an e-commerce platform containing 10,000 rows of data. It was selected because the structure is ideal for analysis, containing mix of numerical and categorical data. This variety enables the creation of meaningful SQL queries to derive statistical metrics. The project is centered around OneCommerce, a premier online retail enterprise that operates on a global scale. OneCommerce offers a diverse and curated selection of products across several key consumer categories. The company operates virtually without physical storefront, managing all sales and distribution through a centralized e-commerce platform and warehouse system. OneCommerce focuses on a set of KPI that derive from the sales data, which will provide critical insights in market trends, operational effectiveness, and customer preferences. The first metric is the average sales of item per month and year, where it calculates average revenue generated per item sold. The second one is the top performing product category, where it identifies the product category that contributes the most of the company's total revenue. Next is the slow-moving items, where it identifies the slowest sales frequency and volume over a given period. As for payment type distribution, it's a statistical breakdown of the payment methods that customers use to complete their purchases. Lastly, for order completion rate, the matrix measures the percentage of all initiated orders that are successfully completed compared to those that end up cancelled, refunded, or may remain pending in the cart.
Hi, my name is Sin Yee. So today I'm going to continue with the presentations of the part 1 of question 3 and 4, which is define the possible relationship in our database, as well as the SQL queries that we have performed. So the database we are actually taken from the table of the frictional e-commerce sales data. And this is the SQL queries that we have performed. So first we are creating the database, which named as big data database. And we will use the big data database. Let me showcase it. So now I have already inside the big data database, and I have created a table named as e-commerce sales to input the data from the .csv files that I have downloaded as the database from the Kaggle here. So to verify that the database have been imported correctly, let's verify it by show the first rows of the e-commerce sales. So as you can see here, the output has been successfully displayed, and it's exactly like the shows as the database in the Kaggle. You can see from the title, order ID, product categories, and so on. So in Kaggle's order ID, product categories, and so on. So it has shows that the data have been successfully imported. And now I will move to the question 3, which is define the possible relations that we identified in our database. So the first one will be the customers, and I have actually created the tables of the name as customers and showcase the relationships. So now I will go through one by one, but I'm not going to create it since I'm already created. So the first one will be customers, which have one-to-many relationship between customer and orders. So let's display the tables of customer. So as you can see here, the customer table has been successfully displayed, and it showcases the relationship between customer ID, name, address, email, with the customer ID as primary key. So the second one will be products, which having one-to-many relationship between products and other items. So to show this, let's describe the product tables which I have created previously. And this is the product tables showcasing the relationship with product ID as product primary key, and the relationship with categories, unit price, and stock quantity. And the third one will be the orders, which having the connections to customer via customer ID, and the connection with order item and payments via order ID. So let's just show the table of orders. So it's showing the relationship with order ID as primary key and customer ID as foreign key, and the relationship of orders and order date and with order status. So the fourth one will be the order items, showcase the many-to-many relationship between orders and products. So you can see from here, it having the relationship with order item ID as primary key, order ID, product ID as foreign key, and the relationship with quantity and the total of price. The last will be the payments, with having one-to-one relationship between payments and orders. So you can see from here, payment ID as primary key, for order ID as foreign key, and the relationship with payment type and payment date. So that's all from me. Thank you.
Hi, I'm Leong. So I will walk through the MongoDB for the NoSQL query. First, we will create the collection. This step is to import our data. So I already import our data as a CSV file. To perform the step to create the collection, click on the aggregation part. I have saved the query here. So to click edit, we can see the whole query. Run it. You create an order collection here, same as the customer collection. Here is the whole query. Run. You create a customer collection. The next part, I'll be showing the query that's similar to our first part. First is the average monthly sales. Click at the order collection, same as the first part aggregation. Look at our first query and then run it. The second one is the best selling category. This is a query. Run. Here is the result. The third one is the which item are not selling. So we can see the query here and then also run it. We will output the category. The fourth query is how does the customer pay. So here's the query. So here are the results. The last query is the order being completed or how are the status of the order. Here's the query. Run it. So here is the result. So all of the result of the query can be exported here in a CSV file. Thank you.